In 1953, the British equivalent to the CIA, MI6, were investigating a lead in Germany. A Luftwaffe engineer had claimed that he worked on a top-secret flying saucer in the mid-1940s, but all evidence had been destroyed as Germany began losing their foothold in World War II. He claimed the saucer flew by riding on top of a cushion of air. Avro Canada's chief designer, John Frost, was in the meeting, and a few years later, Avro Canada had developed something strikingly similar. John Frost developed an interest in swept wings as an engineer at de Havilland. Swept wings are wings that are angled backwards, which delays airflow from going supersonic and decreases the drag associated with supersonic flow. During his time working on the CF-100 Canuck, Frost found that a plane's speed is influenced more by its shape than the thrust generated by its engines. Frost, with all of his experience, soon developed an idea for a plane that was equally aerodynamic in every direction. Specifically, he wanted a plane that could take off and land vertically, hover, and fly supersonic in every direction. Frost was given permission to proceed with what was called Project Y, in which he handpicked 8 engineers to design this aircraft that he claimed would be able to reach 1,500 miles per hour. For reference, the F-100 Super Sabre could fly at about 860 miles per hour around this time. Project Y was initially spade-shaped, which to me looks quite similar to NASA's wingless M2 F1. Funding quickly dried up for Project Y, but Frost pushed forward with his idea. So let's cover what we know right now about Frost. First, he was interested in swept wings. Second, he knew that speed was influenced more by aerodynamics rather than engine power. Third, he was confident that his design could reach supersonic speeds. Also pretend that you didn't see the thumbnail. Knowing all this, let's look at the genius design that Frost proposed. Luckily for Frost, the US Airforce became interested in what his design offered, and funded his project. Luckily for the US Airforce, Frost claimed that this new design had a range of 1,000 miles, an operational ceiling of 100,000 feet, 20,000 pounds of thrust, and a maximum speed of Mach 4. The design initially had 6 engines that would power a central turborotor, and had ducting towards the edges of the saucer, where vents and flaps would allow sideways thrust for steering. With the ground effect, he estimated that the engines could generate 30,000 pounds of thrust. His initial design was a 30-foot wingspan, diameter, a 30-foot wide plane. However, the 2 initial prototypes were only 18 feet, which required the plane to scale down to just 3 engines. This was no worry for Mr. Frost, though, as he estimated that the prototypes could still fly at 300 miles per hour at 10,000 feet. One prototype was sent to California for wind tunnel testing, while the other stayed in Canada for flight testing. They finally had their prototype, the physical manifestation of years of speculation about mysterious flying saucers, secret Nazi aircraft, and claims of incredible maneuvers and speeds. They finally tested the plane, and it went 35 miles per hour at 3 feet off the ground. They found that it was incredibly unstable above 3 feet, and that it would start to wobble like a coin above that height. In fact, it was so unstable that most of its flights occurred tethered to the ground. According to Flying Magazine, a major problem was that the extensive ducting inside the aircraft led to major losses in thrust, causing it to never be able to fly outside of the ground effect. And could you imagine, at this point, that the wind tunnel results showed that the design was extremely unstable and would become uncontrollable well short of supersonic speeds? I know, it's extremely surprising. With these results, the Air Force pulled out of the project, having invested $7.5 million, killing the project. Avro Canada would shut down just 1 year later in 1962. And you know what? I'm sorry, but we need to have an honest discussion here. Why would they expect this to work? I know it was the 50s, but let's be realistic. Do you remember what I told you about Frost? He was interested in swept wings, aerodynamics for speed, and supersonic flight. So he decided to make the aerodynamic equivalent of a cookie. And he also realized aerodynamics were more important than having a powerful engine, but his design failed because it was incredibly unstable and had an extremely inefficient engine. I have a bachelor's degree in aerospace engineering, which in simple terms means I know nothing, but I will do my best to provide a high-level analysis of why I think this is an absolutely horrible design. First is something I talked about in a previous video, the area rule. It basically says that the cross-section of a plane must vary slowly to prevent strong shock waves and wave drag. You can see from the planes around this time that they kind of have the typical pointy shape that fast aircraft have. Now tell me what's wrong with this image. The plane was as sharp as a pancake. I can only imagine that if this plane got even close to the speed of sound, the wave drag would be huge. To be fair, the area rule was discovered around this time, but still, other plane designers seem to understand that narrow equals faster. Next is the stability of the plane. The most common way to describe stability is using a marble. So say you have a marble in a bowl. If you move it up the wall, it'll return to its starting position, and this is called static stability. Neutral stability is like a marble on a flat table. You move it side to side and it just sits there. Static instability is a marble on top of a bowl, where if you move it, it'll roll off the side of the bowl. Static stability is typically what you want for a plane, though there are exceptions. So now we can look at the wind tunnel results. There's a declassified document that lists some of the details of the issues encountered. The first is that the lift curve slope was low, and the plane needed a large angle of attack to generate enough lift. This lift curve describes how much lift is generated with the angle of attack. The greater the slope, the more lift is generated for a change in angle of attack. A small aspect ratio, which is the wingspan squared divided by the wing area, will decrease the slope. Seeing how the wing was a literal circle, the aspect ratio was very low. The next issue is that the saucer tended to pitch up when moving forward. Now if I had to guess, because the saucer was designed to fly in every direction, it would make sense that the airfoil would be symmetric from left to right. On an airfoil we can mark 3 important points: the center of mass, the center of pressure, and the aerodynamic center. The center of mass is exactly what it sounds like. The center of pressure is where you can place a force vector that represents the resulting forces from pressure, and the aerodynamic center is where the moment about the airfoil does not change with angle of attack. What's important for longitudinal stability is placing the center of gravity in front of the aerodynamic center. This creates a CM versus alpha curve that looks like this, which basically means that if the aircraft is perturbed, it will return to its trim position. This is the equation that describes this. The moment around the center of mass is the moment about the aerodynamic center plus the distance between the 2 points times the lift. You can see how putting the aerodynamic center in front of the center of mass will introduce a negative sign into this equation, reversing how the pitching moment reacts to a change in lift. The new CM versus alpha curve looks like this, showing that with an increase in the angle of attack, the plane will continue to pitch up instead of returning to trim. Typically, the aerodynamic center is about at quarter chord. The problem with the left-right symmetric airfoil is that the center of mass is at the center. This means that the aerodynamic center would be in front of the center of mass. In a typical airplane, this could be offset by a horizontal tail, which is inherently stabilizing. But this Frisbee didn't have one. Now, because the airfoil is left-right symmetric, the aerodynamic center could at best be right on top of the center of mass, which is neutrally stable. Another listed issue was significant rolling moments and side force from air entering the turbo rotor while moving forward, which again, it had no control surfaces to counteract this. Another reason this could be from is gyroscopic moments generated from the giant fan that only spun in one direction. A second rotor spinning in the opposite direction could have counteracted this. Or, any control surfaces. So that was what I saw here. If you see anything else or disagree with what I had to say, feel free to let me know. This saucer just seems incredibly unstable all around. It has to contend with a large turbo rotor, strange aerodynamic shape, and a complete lack of control surfaces. Now, many modern fighter jets are intentionally statically unstable, but they make up for it with these control surfaces in modern fly-by-wire systems, things that 1950s Avro Canada did not use. One of the sources I read tried to justify the shape by saying, its circular shape, while seemingly odd, isn't that far off from the shape used by reusable spacecraft to manage the extreme friction and heat of re-entry while keeping behavior and air currents predictable. But guys, let's be honest, it's not shaped like the Apollo capsule. It's just a circle. The point of the bottom of the Apollo capsule was to slow it down in the atmosphere and to act as a heat shield. There is no reason to apply that logic to this saucer, which was intended to do something completely different. Plane Historia also mentioned that some conspiracy theorists believe that the flying saucer project was secretly a massive success and that the reports of the Avrocar being terrible are just a cover-up.
You serious?
But taking everything I talked about today into consideration, if they are right, I will throw my degree straight in the trash because there is no way this thing was ever going to be successful. If you made it this far in the video, thank you so much for watching, and please consider subscribing. I'll have more videos coming soon. Bye.